Hello, I'm Rajiv. We'll be doing a step-by-step example working with sampling distribution models for proportions. Here's the example. Suppose that about 13% of the population is left-handed. A 200-seat school auditorium has been built with 15 lefty seats, seats that have the built-in desk on the left rather than the right arm of the chair. Here's a question we want to look at. In a class of 90 students, what's the probability that there will not be enough seats for the left-handed students? Let's state the problems. We want to find the probability that in a group of 90 students, more than 15 will be left-handed. Since 15 out of 90 is 16.7%, we need the probability of finding more than 16.7% left-handed students out of a sample of 90 if the population proportion of lefties is 13%. Now that we have stated the problem, we need to think about the assumptions and check the conditions. Independence assumption. It is reasonable to assume that the probability that one student is left-handed is not changed by the fact that another student is right or left-handed. If the students were related, we may question this assumption, but it seems reasonable for this example. Randomization condition. The 90 students in the class can be thought of as a random sample of students. 10% condition. 90 is surely less than 10% of the population of all students. Even if the school itself is small, think of the population of all possible students who could have gone to the school. The success or failure condition. N times P equals to 90 times 0.13, which equals to 11.7, which is greater than 10. N times Q equals to 90 times 0.87, which equals to 78.3, which of course also is greater than 10. Now that we have determined the assumptions and conditions are satisfied, we can state the parameter and the sampling distribution model. The population proportion is P equals to 0.13. We'll model the sampling distribution of P hat with a normal model with a mean 0.13 and a standard deviation of P hat which equals to the square root of P times Q divided by N, which equals to the square root of 0.13 times 0.87 divided by 90, which equals to 0.035. Our model for P hat is N of 0.13 and 0.035. There are two ways to determine the probability, using the calculator and using the Z formula. First, I will show you the Z formula. Taking a look at our Z-score formula and filling in our numerical values, we have 0.167. Again, we are looking for the probability of more than 16.7%, minus our p-value of 13% divided by the standard deviation value that we just calculated of 0.035. This equals to 1.06. Using your Z table, you can look this value up to find that the probability that Z is greater than 1.06 or the probability that P hat is greater than 0.167 equals 14.46%. You see a graph of the normal curve with the shaded in region we just found. Now we perform this calculation on StatCrunch. We go to StatCrunch, we click Stats, Calculators, and Normal. So we'll put for the mean 0.13, the standard deviation 0.035, and first we would like to find the probability of x being less than or equal to 0.167. And we compute. This is then equal to 0.855. The next value we would like to compute, the same mean and standard deviation, but the probability of x being less than or equal to 1. Upon computing this, we find that the probability is identically 1. Now we subtract the two values. 1 minus 0.855 which equals to 0.145. Let's state our overall conclusion. There is about a 14.5% chance that there will not be enough seats for the left-handed students in the class. This ends our example working with sampling distribution models for proportions. Thank you for watching.